Hello everyone, today we're going to do some exercises with monomials. So in the last theory video we saw some operations with monomials, how to handle these operations, and today we're going to do some more exercises so that you can understand better what we're talking about. So the first exercise consists of simplifying the following expression. Okay, of course, the result may not be a monomial, but we don't care about that. The important is that we have monomials inside our expression. That's the main goal, to just know how to do these kind of expressions. So, I'll start explaining the answer in 3, 2, 1. Okay, so the first thing you want to do, at least now that you are beginning to get into monomials and their operations, is like underlining or coloring with a color pencil the similar monomials. This is something I always did when I first started with monomials because it's really easy to get lost. It's extremely easy. Now that we have this, it's much more clear how we can handle this situation, because we know which monomials are similar and which are not. So I would like to note that we can get rid of those opposite monomials. So we know that the algebraic sum of opposite monomials is always 0. So in this case we have 3a squared and negative 3a squared. Of course they are opposite, and so we can simply get rid of them because their sum will be 0. Now we can just rearrange everything so that we have a's on the left and b's on the right. Of course this isn't very important, but in my opinion, when you are beginning to get into monomials, it's really effective to follow this structure. So now we can see that we have 5/3 a squared plus 1/3 a squared. So they have the same denominator, so we're simply doing the addition in the numerator. So we're going to see 6/3 a squared, that we can simplify because they are both divisible by 3. So 6 divided by 3 is equal to 2, and 3 divided by 3, of course, equals 1. And then we can also do the other fraction, so the other fraction with the b's, because we see that the common denominator is 2, and so 19 minus 5 is of course 14. And since they are both the numerator and the denominator are divisible by 2, or rather are divisible by 7, or by 2, sorry, this means that 14 divided by 2 is equal to 7, and 2 divided by 2 is equal to 1. Now we can rewrite everything. We see that we have got another pair of opposite monomials, and so we can get rid of them, because 2a squared and negative 2a squared, of course, are opposite, so their algebraic sum is equal to 0. So now we have our final answer, negative 6b squared plus 7b squared, which equals b squared. Okay? If it helps, you know that there's the commutative property of addition. So what you can also do is 7b squared minus 6b squared. That's exactly the same, and you see that the result is b squared. If you find that easier, or as we said in the last video, if you can't really see how you can do these operations with letters, just think about an object. If I have 7 apples and I subtract 6 apples, how many apples do I have left? Of course, I have 1 apple left. Since the number 1 as coefficient and as exponent is usually omitted, we are simply going to write b squared. But of course, the coefficient of b squared is 1. 1b squared, of course. Now, let's go on. Here we are still going to simplify this expression. Pause the video if you want to solve it by yourself, or else I'll start explaining in 3, 2, 1. So First of all, since we are just getting into the world of monomials and literal expressions, having also to deal with fraction is usually something we don't want, especially as beginners. So let's just make things as easy as possible for us. So let's write the denominator of number 3. Of course, this may seem trivial and useless, but believe me, if you are a beginner with monomials, then this can really help you because it's much easier to do calculations if you have problems with the letters. Now, we can see that 4 and 8 can be simplified, both divisible by 4, so we can divide 8 by 4, which is equal to 2, and 4 divided by 4, which is equal to 1. Then, if you pay attention, we see that the 5s are also going to be simplified. And if you pay also closer attention, you can see that the 2 that we got dividing 8 by 4 can be further simplified with the denominator of the fraction 5/4 a squared b, which now is 1/2 a squared b. Now, what we want to do is to multiply. So, as I said, this is just for clarity, but if you have problems with letters, if you struggle with letters, then there's no need to struggle also with fractions. So make things as clear as possible for yourself, okay? So we have a product. We just multiply the denominators at the top and the bottom. We just multiply the denominators. That's why I put the number 1 in yellow. And then we can just put the negative signs there so that we know what what the sign of the result will be. So negative times negative, of course, equals positive. Then all those ones times 3 equals 3, and all those ones multiplied by 2 equals 2. So we have positive 3/2. And now the only thing we need to do is multiply the letters. Okay, when we multiply letters, just sum up all the exponents. And just to make things easier, we can get rid of that a to the 0th power, which is simply equal to 1. Okay, that's completely useless. Now we can get rid of those silly parentheses thanks to the associative property of multiplication. That is, if we have 3 letters, a times b and then multiply that by c is equal to doing a times b times c. Okay, that's exactly the same. That is why we can get rid of those parentheses. And now it's just a matter of summing all the exponents, and here it is, the result. 3/2 a to the 6th b to the 6th. In this case, we got a monomial as a result, but it's not a certain fact. We could also get something that isn't a monomial, okay? But in this case, we did get a monomial. Now, let's do something a bit more complicated. So, let's start. Now, we see that we can simplify, since we have multiplication. We see that we have a lot of negative signs, so it's easy and probably better to remark them so that we know how the result of that multiplication, whether the result of that multiplication will be positive or negative. Now, everything is much easier, more compact, I would say. Can get rid of that positive sign and also of some parentheses which aren't important at all. Now we see that we have similar terms. All these are similar monomials. They all have the same literal part, x cubed. That's equal for everyone. Common denominator 2, okay? And then we can just make the sum of all the numerators, and 2 over 2 x cubed, which simplified equals, of course, x cubed. So also in this case we get a monomial, okay? By the way, if anything's not clear, feel free to comment in the comment section below. Now, let's switch to exponents. We are going to do a couple of these really simple warm-up exercises and then get into a real expression. So we see that there are a lot of parentheses, that's for sure. But if you pay close attention, we have a zero exponent. When we have zero, everything that is inside, we may also have a million parentheses, anything, but the result will always be 1, okay? Of course, given that the thing inside is not 0, because if 0 to the 0th power, that's something we do not like. That's similar to 0 over 0. But in this case, we definitely can, okay? We definitely can. Because we're dealing with letters. We should say m different than 0, okay? Because if m is equal to 0, then we would have actually 0 to the 0 situation, but in this case it is not required, okay? We're just omitting that information for the sake of this video. So we see there is 1 to the 3rd power, 1. Okay? Really simple, concise. Let's do another of these really warm-up exercises. So in this case, we can simply multiply the exponents as a power of a power, and the result is simply negative x 9y. Okay? These are really warm-up exercises. There is no need to do them individually. We can see them together because they are just to get into the mood. Okay? Now, instead, we're going to do definitely something much more challenging. I'll start explaining in 3, 2, 1. Okay, so as I said before, let's just make everything more clear by highlighting the powers and the negative signs. Because we know that if we have a even power, then the negative sign will simply cancel out. Okay, so this is why I highlighted the even exponents and the negative signs. So we can get rid of them, which are just a waste of space in my opinion. And now we are going to compute the powers. So just to be specific, we can see that it's basically for everyone the same. We are going to raise basically the exponent to the number, as you can see here, while for the other letters we are going to do a multiplication. This is because it's the power of a power, as in the last exercise. So this is the reason for what we're doing right now. Okay, I will not explain for all of these. It's the same as well. It's the same for everyone. So now we get to this result once you do all the multiplications and the exponentiations. And you can see that there is some simplification we can do. In this case, it's negative 8, so we can change the negative in front of everything to a plus. There are some opposite terms, so we can simply cancel them out. And the expression is much, much easier. There is some simplification, though, we can do. And now we see that we have reduced that monomial to normal form. This is why it's really important. We did that also in the last exercise video, reducing normal form. And we can see that now those two monomials are similar. We can add them up. And in this case, the result is not a monomial. Okay, don't worry. It's not that you are wrong. It's just the exercise. So the exercise was about monomials. As you can see, the expressions were all monomials. However, the result was not a monomial. Why? Because we do not have similar terms. Okay, if you have 3 lemons and you add up 2 apples, you will not get a banana or anything like that. You will still have those 2 separate. Okay, so don't worry, it's not a mistake. It can happen in most exercises. It will happen, but actually this is a right and valid solution. Now we can also do this exercise. Okay, so or we can get rid of that parenthesis. I hate when textbooks put all those parentheses, they are useless, okay? Because for the, as I said before, associative property doesn't matter which sum first, okay? The order of operation matters, okay, in this case. Then same thing, just that minus sign, since we have a positive, an even power that will just become positive, and everything else we can just change signs, okay? Because there is a multiplication and division in between that is valid, okay? When we divide signs or multiply signs, then we know the same arithmetic rules. As I said before, use a colored pencil, underline in different ways to show that those are similar, and then we just do a common denominator. And here I also let's say I developed the exponents, okay? So 2 to the third power is equal to 8, 3 to the third power is equal to 27, and minus to the third power, which would be minus times minus, is simply minus, okay? Divided by 2 to the second power, which is 4, 3 to the second power, which is 9. And then for the letters, we are multiplying the exponents, okay? As I said in the last video, when we do not have a number, it's simply 1. So 1 times 2 equals 2, and 1 times 2 equals 2. Here we can see that I have this y here, this extra y, which comes from here, okay? This is the reason why we have an extra one. And this was in the original text also, okay? We just changed sign because there was a multiplication in between. Now we can continue, we can simplify, okay? In this case, we could put a multiplication and do the reciprocal, so we would do 8 over 27 times 9 over 4, but we can be faster and just do it like that, okay? We know that, again, other simplification, put that exponent there and do the subtraction, sum them because we have a multiplication, and now we have similar monomials, okay? And this is the answer, because the denominator is 3, so it remains 3, and for the numerator we're going to do 4 minus 2, which is 2, of course. The literal part does not change because we are doing an operation with similar monomials, okay? If you have 3 apples and then eat 1 apple, we have 2 apples, okay? It's not anything different. We do not have 2 cucumbers, we simply have 2 apples. The literal part does not change, it remains there, okay? Now, let's do something trickier, okay? Let's calculate the greatest common factor and least common multiple of the following monomials. So to do this, we are using the table that we saw also in the last video, because I think that at least when you begin with this, it's always better to make things as clear and as visually comprehensible as possible, okay? So we put there our monomials, and then let's see x's, y's, and z's in the different monomials. So of course these are the values, the exponents of x in the monomials, okay? I also put x for clarity, okay? The same with y's, and the same with x. Now, when we want to calculate the GCF, we want also to know the coefficient, okay? Since we all have, the coefficients of the original monomials are all, okay, they are all integers, then we definitely can make a GCF out of that, okay? Because if we had like a fraction or a floating point number, then we would need a 1 in front, okay? So we simply need to grab that number we got there, and then the smallest, repeat, okay, the smallest number there with the exponent, the smallest exponent, okay, with the letter. So This is why the result is this. Remember that when we talk about GCF, is like if you divide this monomial by any of the original monomials, you will get another monomial. Okay, this is the main thing. So if you do 15x to the 5th, y to the 4th, z to the 6th divided by 5x squared and so on, okay, you will get a monomial. If you do 5x cubed y squared z cubed divided by 5x squared and so on, you will get a monomial. Okay? If you do 10x squared y to the 4th z to the 4th divided by 5x squared and so on, you will get a monomial. This is the meaning. Okay? This is what we are saying. Since the numerator has larger numbers, or at least equal numbers, talking about coefficient and also the exponents of the letter, the result will be a monomial, as we saw in the last theory video. Whereas when we calculate the LCM, we want kind of the opposite. Okay, so if you calculate the LCM of those numbers, you will get 30. Why? Because you're going to do 2, okay, times 3 times 5. Yes. So basically you're doing 15 times 2. Okay. Where did I pick those numbers? Because 15 is equal to, in prime decomposition, of course, factorization, 3 times 5. Okay. 5 is equal to 5, and 10 is equal to 2 times 5. So we're going to get all those numbers with the largest power. In this case, the largest power is just 1, and so we're just going to do 2 times 3 times 5, okay? Which is 30. So to calculate the LCM, we're going to put that coefficient and then choose the largest exponents, the letters with the largest exponents. Why? Because here what we want to do is not the original monomial divided by the GCF, okay? No, it's slightly different. If you do 30x cubed y fourth z to the 6th divided by 15x cubed y to the 3rd z to the 6th, then you will get a monomial, okay? So the main thing is that with GCF, if you divide the original monomial by the result of the GCF, you will get a monomial. With LCM, if you divide the LCM by the original monomial, you will get a monomial, okay? It's a slightly different operation, okay? But the thing is, you want in the end to get a monomial, okay? In the future videos, we will definitely use more often LCM, okay? Because when we have fractions, as you know, with numbers, we do the common denominator, and with if we have letters, we need to do something similar, okay, which is thanks to the LCM. That's why we are doing that here. So thank you, see you in the next video. Bye.